I started making you this video and then I accidentally lost it all. But I was only a couple minutes in, so I'll just make it again. This is about computing in scientific notation. Yay, this is everybody's favorite thing. Trust me. Actually, it's not that bad. Um, Let me just show you. Basically, this problem's mean because first it makes you convert into scientific notation, then it makes you do math in scientific notation. But let me just show you some tips. So basically, 0.09, we got to figure out some number equal to 0.09 in the form blank times 10 to some power to something here. Okay, so you know this number here has to be less than 10 and greater than or equal to 1. So basically you just use the first non-zero number, and that's a 9 here. And now you got to say, what's the exponent going to be? Now this number that we're starting from is less than 9. 0.09 is less than 9. So I know it's going to be a negative exponent. And then I basically just count how many places does the decimal move. So the decimal moves 2 places to go from 0.09 to 9. So this is going to tell me it's 9 times 10 to the negative 2. And we can check this work because if you don't know this, so positive exponents, you probably know, that's when you multiply by that number that many times. So like 10 to the second power is just 10 times 10. There's 2 tens multiplied. If it's a negative exponent, it basically means you can either think of it as 1 over 10 squared. That equals 10 to the negative 2. And so you basically are dividing by 10 that many times instead of multiplying. So if we have 9 times 10 to the negative 2, you can either think of it as, you can think of that as 9 times 1 over 10 squared, or you could think of it as 9 divided by 10 divided by 10. Either way. And that gives you 9 times 1 over 100, which is 10 squared. And that's 9 hundredths, which, as you can see here, our original number is 9 hundredths. Magic. That is magical. So we know that 9 times 10 to the negative 2 equals our original number, which is good. That's what it's supposed to equal. And then, so now I'll convert this other number, 30,000, to scientific notation. 30,000. So we're going to do the same thing again. It's blank times 10 to some power. So the power for this one, well, let's see. First of all, let's figure out this number. Our biggest non-zero number is 3, which is less than 10 and greater than or equal to 1. And we got to figure out what the exponent is. Since 30,000 is bigger than 3, we're going to be multiplying by 10 several times. Not dividing by 10, multiplying by 10. So this is going to be a positive exponent. That's a plus. And then we got to see how many times the decimal move from 3 to get to 30,000. So if we have 3.00000, how many times the decimal place have to move to get to 30,000? So there's going to be 4 zeros. It's going to get 1, 2, 3. It's got to move to here. So it's going 1, 2, 3, 4 times it moves. So this is the 4th power. So now we have this new problem here. So I'm just going to replace putting in the values we calculated that are equivalent. Now what I do to calculate this, I basically, first I just take all my numbers here. My 2, my 9, and my 3. Everything that's not a 10. And first I calculate that. So that's going to be 9 over 3 times 2, which equals 9 over 6, which equals 3/2. That's a 9, not a 4 right here. This is a 9, just so you all know. Okay, that's a 9. Cool. So now I got to figure out what the all these 10s are going to become. So I got 10 to the negative 2 over 10 to the 4th times 10 to the 9. Alright, so basically what you can do is just add everything that's on the same line. So I'm going to add all the things on top. I mean all the exponents on top and add all the ones on bottom. So what I mean by that is like this one's just going to stay the same on top. I'm going to add the bottom exponents together. So that's 10 to the 13. And then I'm going to subtract from the top to the bottom. So negative 2 minus 13 is 10 to the negative 15th power. So that's basically the answer. It's going to be 3/2 times 10 to the negative 15th power. And 3/2 is 1.5. Now wait, before we write that in, I want to make sure that this is a number in scientific notation. So let's see. Is it in the right form? My first number is less than 10 and greater than or equal to 1, so that's okay. And then it's times 10 to some exponent, so that is in the correct form. So I'm going to write it out. 1.5 times 10 to the negative 15th power. And now you're like, why did I get it wrong? And I'll tell you, because I forgot to write my negative 9 here. This is supposed to be negative 9, as it's shown in the problem, and I just copied it down wrong. So now I'm going to check my work again. So this should be, instead of 4 plus 9, it's 4 minus 9. You're going to get negative 5. So now I do negative 2 minus 5, and I'm going to get minus 7. So that's not minus 7. So look, I'm a math major, and I even made a mistake. So don't be hard on yourself if you make mistakes. Just it's good to check your work and make sure when you're copying things down, you double check everything's copied right, or else you get it wrong like I did. Oh, now what did I do? And now I got it wrong again because I was so like, oh no, I got it wrong in the video. What did I do wrong? That I did negative 2. I did negative 2 minus negative 5 as equal to negative 7 when it's actually equal to 3. And you see I even checked the hints and was like, oh duh. That's just one of those things where it's like, I knew that, but I was in a rush. And so I'm showing you my mistakes so that you know everyone makes mistakes, and because I don't want to re-explain everything I just did. So everything I explained was right. My errors were, I forgot to copy this negative, and I added wrong. So those are my mistakes. So, oh well, now it's right. I'm going to do another one. Oh, perfect. This one's already in scientific notation. So last time, I didn't make mistakes converting to scientific notation. So you can, at least you know how I did that before. I'll just show you how to calculate this time. Whoa, that was really sloppy. So basically, it's 1.2. Alright, make sure my decimal's there. Making sure, be extra careful this time, because last time bad things happened when I wasn't careful. So what does this equal? Okay, I know that this equals, I'm just going to calculate this in my head really fast. Right over here, 12, 8, it's going to be 3.2. 3.2. Pretty sure that equals 3.2. Oh, you know what? I think there's even a calculator built in down here somewhere. You're allowed to use a calculator. So 3.2. Let me just double check. 1.2 times 8 over 3 is 3.2. Cool. So 3.2. And now I gotta figure out what all these guys here are. Now this time I'll be extra careful because last time I was sloppy and rushing and messed up. So let's see. I add on top. So negative 6 plus negative 4 is negative 10. I add everything on the bottom. There's only one thing on the bottom, so that's not very hard to do. And I get 10 to the negative 3. Now, I have to remember 10 to the negative 3. Dividing by 10 to the negative 3 is the same as 10 to the negative 10. Instead of divided by negative 3, I can multiply by 10 to the positive 3. And that will make it easier for me to add without messing up. So that's going to be 10 to the negative 7. So there we go. Let's see if I'm right this time. If I'm not, then ignore everything I've told you. It's all wrong, and I'm terrible at teaching math. Oh, phew, that was close. Okay, I got it right. Oh, this one looks annoying. So I'll show you how to do it. Alright. Okay, this isn't as bad as I thought. So they're asking what is our energy consumption in watts. Energy consumption rate in watts. It tells us what it is. So I'm just going to abbreviate that as watts. And it tells us it is, so my equal sign is the same as is, the product, so it means something is multiplied, of the input voltage, I'll just call that voltage, times the current in amps. So I'll call that A for amps. Cool. And it's asking me what is the energy consumption rate in watts, which I call W. So I know that it equals the input voltage, which they tell me is 10 to the 4th, times the amps, which is 500 amps. Cool. And it wants it in scientific notation. So watts equals 500 times 10 to the negative 4th. Now it's almost scientific notation, but it's not quite, because in scientific notation the first number has to be between 10, less than 10, and greater than or equal to negative 1. 500 is greater than 10, way bigger than 10. 500 actually can be written as 5 times 100, right? That's what that equals 500. So I'm just, so you know these two are equal to each other. This line equals this line, and that equals 5 times 10 squared times 10 to the 4th. Now remember, when you have some number, if it's the same number to different exponents, you can add the exponents together. So this would be equal to 5 times 10 to the 6th. The reason why you can add that is because, look, 10 squared. So this would just be 5 times 10 times 10. And you're multiplying it by 10 to the 4th. That's just times 10 4 times. Times 10 times 10 times 10. I think that's the right number. Yes, so these 4 are from this. These 2 are from this. See, so really if you take all these together, that's just 10 times 10 6 times, which is 10 to the 6th. So that's why you can just add those together, and now we have it in scientific notation, because 5 is less than 10 and greater than or equal to 1, and it's times 10 to some power. Yay, I got it right. Cool. So I'm just going to leave it at that for you. I hope this is helpful. Let me know if you have questions. Cool, frijoles. That's the end.